Alright, let's get started with the second problem of the day. This is LeetCode number 424, longest repeating character replacement. You're given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English letter. You can perform this at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Okay. Let's see, if we wanted to do that, let's see. So longest repeating character, this kind of reminds me of maybe doing a... Do we care about the middle parts? Do we care? Like, do we care about the middle elements between the first and last indices of our string? I think almost to a certain extent that answer is no. Let me think. Let's try to think of a brute force solution first. We could do a frequency map of each interval. For all lengths between 1 and k, or 1 and s rather, dot length. And we can say if the frequency map has a size less than or equal to k, and the element, or and an element exists such that its frequency is less than k, less than k plus 1, and an element exists such that its frequency is less than or equal to k, then we can convert all of those elements into the other elements if we want. So the idea is, like, for example, if we do a size of 4 with a, b, a, b, so our frequency map has a size of 2, because 2 characters. And if an element exists such that its frequency is less than or equal to k but greater than 0, so this b has a frequency of 2, which is less than, equal to 2, so that's we can convert all the b's into a's into the other element, or we could do vice versa, right? Similarly for this one, if we did like a size 1 will always be, size 1 is like the default, right? So I think between 2. Right, so AA is fine. AB, well, B has a frequency of 1, so it doesn't matter. BA is frequency 1, we can change it. AB, we already know. BB, and that is fine. And then BA, we already know. And then size 3, well, K in this case is 1, right? Because the frequency of B is just 1. So we can convert the B into an A and have a string of length 3. And then similarly, we just keep sliding the window until we get to size 4, where we have AABA. We could replace the A or the B in here with an A, right? So in that case, let's see. We could probably do then a sliding window. I was leaning towards a sliding window. This could potentially bring us down to O of n time, where n is the size of the string, or rather length. And it seems like 10 to the 5 input size, so I think they're leaning towards linear time. So what we'll do is that we can say start with a frequency map of size, or start with a sliding window rather. Size 0 or 1 rather. And while the next element is either the same, in which case we increment frequencyMap, or we have space to accommodate the element, which means that the map.size is less than or equal to k plus 1. Because we know we have one element that we don't need to change, right? And that will be our quote-unquote dominant element. So as long as our map size is less than k plus 1, we're fine. Though we could also note down, like, okay, like how many letters left can we change, right? So we have space to accommodate the element. Add the element to our frequency map and update the values, including max length. Otherwise, we want to slide the window forward and remove back, add front. Until we can add the next element. So the idea is that once we cannot add more elements, we will slide until we can add another element, or until we hit the end. And the reason why this is O of n time is because of the fact that no element will get scanned more than once. Because we will initially build up our sliding window. If we have more elements we can add in, we will just add them into our sliding window, right? And when we slide forwards and backwards, we just add the next element and remove the back element, which is just constant time within our hash map. So, let's see. This will technically take O of 1 space, because we are limited to uppercase English letters. You could also use an array, but the problem with the array is that you don't necessarily know the size of your array unless you check each element, right? So then you'd have to do that each time, or you'd have to update it on your own and keep a value of that. Though that might be a little bit more optimal now that I think about it. Potentially. We could explore that option if we have time. In any case, I think this works. Let's go ahead and give it a shot, and then let's see how it turns out. So so, let's say val frequency map is equal to mutable map of, this will be character to integer. And then we can say var left is 0, var right is equal to 1. S length is at most, or at least 1. So we can say if s.length is equal to 1, we can just return 1, because we don't need to make any changes regardless. And then we can say for index in left to right, we can say frequencyMap.put, we can say our character, or rather s at index, frequencyMap get at s index, or put, we just put in a value of 1 as int, because we need to cast it, because Kotlin is kind of weird sometimes. So get or put, so we either get the value or we put a value of 0 in there actually, and then we add 1 to it. So we set up our frequency map, and then we can say while right is less than s.length, and then we can say in this case while, let's see, right, let's see, probably actually -1. While the right side, or the index, frequency map dot put s at index, or right, get. While we get this is not null, maybe we should keep a value or keep a reference to how many different letters we can add. Let me think about this some more. So the number of letters within our frequency map, or size of frequency map, is the number of different characters. And we also need to keep track of the number of other letters we can still add. So we need like a dominant character kind of thing. So we'll say frequency map dot for each entry. So we can say dominant character is equal to s at 0 if entry.val is greater than frequency map dot get our dominant character, then our dominant character is equal to entry.key. And this will be something that we will also do later. And then the idea is that we use this dominant character, get the number of letters that we have of that character, and then the rest, because they are less, will be transformed to the dominant character. Right, because it'll always be more effective for us to transform characters to the dominant character rather than to a non-dominant character, because we would then have more letters to convert to the other. And then we can say var characters left to transform is always going to be equal to k minus dominant frequency map get dominant character. Or rather, so say we have a sliding window size 2, and we can only transform 2 of them. Let's see. Is it rather than k, this would be right minus left plus 1. So the size of the string, and then we can only transform the number of elements equal to k. Okay, no, we can only transform up to k elements. Like, let's say that we had this, right? So B, A, B, B. And then we had a k value of 1. Had a k value of 1, then there's only one letter to transform. That's correct. Maybe it's like this. So it's right minus left plus 1. So the size of the string minus our dominant characters minus 1, or k minus that. If we had a size of 2 like this, and we subtracted our frequency dominant character, so that'd be 2 minus 2, that's 0. And then we can do k minus that amount. So for example, if we had BBA, then we had a size of 3, a dominant character size amount of 2. And then, so 3 minus 2 is 1, and 1 minus 1 is 0, so we have no more characters to transform. Okay, so I think this equation works. Okay, so that's the number of characters that we can transform. And characters left to transform is greater than 0. Then we can say if frequency map get s right, or actually rather if s at right plus 1 rather is equal to dominant character, then we can just do frequency map dot put at dominant character, frequency map dot get at dominant character as int or 0 plus 1. Though realistically, this should not be null. This get will never be null because we know that dominant character exists in this context. Otherwise, we can do frequencyMap.put into our s@right plus 1. And then frequencyMap get at s@right plus 1. And this will be a get or put. 0 as int plus 1. And then we will say characters left to transform minus minus, because we've just added another character to transform. However, we should also do if frequencyMap.get s@right plus 1 as int do we need to do this? Is greater than frequencyMap.get at dominant character? Then we need to kind of reset it. So characters, so dominant character, first of all, becomes s right plus 1. And then our characters left to transform needs to essentially reset itself. Right. Let's just hope that that works. Just do a null defaults. Hopefully I can do this, because it's kind of annoying to do that. Anyways, so while we can grow, we will continue to grow. Then while characters left to transform is equal to 0, then we will say left plus plus. And before we do left plus plus, we will do frequencyMap put at s@left, our frequencyMap get at s_left, minus 1, and if if our frequencyMap at s_left is not equals to is less than or equal to 0. Oops. Then we can do frequencyMap.remove s_left. And then we can say, now we kind of need to reshuffle through the entire thing, because we don't know what the next largest item is, right? We don't know what the next largest or the next dominant character within our frequency map is. So we kind of need to do this dominant character like reshuffling again. Which is a little bit awkward, I think. And then var max length is equal to 1. So if right minus left plus 1 is greater than max length is equal to right minus left plus 1. And the shrinking side is that. And then we can return max length at the bottom. Let's see. And then we kind of need to reshuffle the characters left to transform here, right? Yeah. Should probably do that as well. So this is a little bit messy, in my opinion. Let's see if we can sort of sort through this. So the idea is that we get a frequency map, and we put in all the characters. And the number of characters that we're allowed to transform at our current moment is our k value, which is the maximum number that we're allowed, minus the size of our string. So the size of the string minus how many characters are dominant within there. So that part leaves us the number of characters which are not the dominant character, and k minus that amount will get us the number that we actually want, which is the number of characters we have still left to transform. Of course, we have two locations where that dominant character and the characters left to transform can change. It is either when we are growing or when we are shrinking. So this is the growth part. Sliding window. So when we're growing the sliding window, we check the next element. If the next element is the dominant character, we can just increment the dominant character and be on our way. Because the dominant character is already dominant, we don't need to change anything there. And it will not affect the characters left to transform, because we didn't use up any characters that in order to transform. Otherwise, if it is not the dominant character, then we need to transform it to the dominant character, or reset or change the dominant character, right? So we add it to our frequency map using this. We will decrease the number of characters that we have left to transform first. Then we will check to see if the newly added frequency is dominant. So if the newly incremented or newly added letter is now dominant, which means that it appears more within our array, within our sliding window than our dominant character, then we will set our dominant character to that one, and then we will recalculate the number of characters that we need to transform. Likewise, afterwards, after we have finished growing, we need to shrink and slide our array over. So once we have hit the max point where we can in terms of our array, once we've hit the maximum point where we have grown our array, our sliding window essentially to the size where it is the maximum it can get with transforming, then we need to shrink our left side to move on to the next potential set. So what we do in that case is that we decrement the left side, as well as if it's less than 0, then we just straight up remove it. Then we will check again in our frequency map to see which one is our next, if we have a new dominant character. If we have a new dominant character, then we need to modify then we need to modify our dominant character and update it, right? Then we will increment our left side, and then finally we will update our characters left to transform. Our characters to transform really only matters if we modify our dominant character. So I'm actually going to move it here. So the idea is that if we move a character, if we remove a character and that happens to be the dominant character, and that dominant character happens to stay the same, then we don't need to change the number of characters left to transform, because it doesn't matter. We didn't change it, right? because that wasn't a character that was transformed in the first place. If we do change it, however, then we need to modify how our array looks, or how many characters we have left to transform. And then we continue moving that until we hit a point where we have enough characters that it doesn't matter. And then at the end, we just return our maximum length, which is defined as the longest length after we've grown our array to the maximum possible. Let's go ahead and run a compile on it just to see if it actually compiles. And then we'll see if there are any issues with the... we'll see if there are any issues in terms of actually the implementation. So we need to wrap these. That's line 61 is not, it's not happy about it, but I think in all cases it's probably not happy about it. So let's just wrap the values inside these parentheses. Because I think Kotlin is a little bit squeamish about using the Elvis operator without wrapping it properly in parentheses. It can get confused very easily. Seems like that's most of them. Looks like you. Also need that treatment. If entry.val, I think it's entry.value, and this probably needs to be wrapped in parentheses as well. Let's go ahead and take a second compile and see where we end up. Entry.value here as well. And you need a an Elvis operator as well. Looks like we might hit a TLE. Interesting. Ah. In this case, if we've incremented the right side already in the top part, because we run this, right? So then these only need just need to be defined as the right. We can do a little print line and say right, left. Though now I wanna make sure that's in order. Let's see. Looks like we hit an out of range. While right right is less than s.length, and then we can do this actually. So right plus plus, so we just keep on growing as long as this is not there. Then we want to do this before before the null. It's a little bit weird because then we're using plus plus right in this case. So we need to make sure that we put this character's left to transform here beforehand. Looks like we're getting a little bit of an issue here as well. Let's see. Index out of bounds on this line? On line 57? Left? Print line left, left, right, right? Which one? I'm sorry, which one is left? Or which one is getting out of bounds? 0, 1, 2, 3. That's in bounds. Into S left. Frequency map get S left. What is out of bounds here? Left is 0. And this doesn't matter because once we hit the right side, then we know that we've hit a maximum, so I don't think that matters then. I think once the right side hits the maximum, then we can just return. So if right is equal to s.length minus 1, greater than or equal to realistically, then we just return max length. I'll take a look at you. Left plus plus. You're in, yeah, you're still in there. How is 59 running into an out of bounds? I'm just so confused about how this is running into an out of bounds. Let's actually throw you in here so we get to see what's going on. Interesting. Well, left is less than right, and that. How am I hitting a TLE now? Well, left is less than right. Ah, I see. No, that won't work. That? Huh. Looks like it's breaking at that point, though. So we go to 0, 1, then 0, 2, right? And then here, we can print line like the dominant character. Should probably become, it would probably stay A, right? And in this case, we can continue, right? We can get rid of this stuff for now. Oh, keep it for now. 0, 2, then dominant character. Then we move up to let's see. We want to say actually, while right is less than s length and frequency map get at s right, or rather s at right plus 1 is equal to dominant character. And then we want to do this first. So frequency map put s at dominant character. Frequency map get dominant character or null or 0 plus 1. And then right plus plus. Actually, we could do this. Right? And less than -1. So we grow the sliding window to as much as possible using the dominant character first. Then, while we do this, and the character is left to transform is greater than 0. Then we do this with non-dominant characters. Then we do that. Characters left to transform minus minus. And then if there are more dominant characters, then we do that. Let me think. Shrink and slide if we have no other choice. But it feels like this can kind of go back and forth on its own, right? This could kind of be perpetual on its own. So as long as we're not hitting the end, then we can add to the right side the value we get, decrease the number of characters left to transform. But if there is a new dominant character, then we reset the characters left to transform. Kind of want to move this inside a block, but no, we probably just want to keep this in a block. If we want to move that into a block, what would it be? I guess while characters left to transform is greater than 0. Greater than 0. Let's see. So while we can grow the sliding window either from dominant character or transforming others, then we want to grow the sliding window to as much as possible with the dominant character. We also want to grow the sliding window as much as we can with the dominant characters and update the dominant character if needed. Let's see. And then we will update the max length. If we are at the end, then we just return the max length because there's no other way that we can grow it further. Anything else is just shrinking. And then while characters left to transform is equal to 0 and left is less than right. Then we move the left side up, the dominant character, and then we can say like characters left is characters left to transform. So this should grow. So AA, this B takes it down so that the characters left to transform is 0. Well, characters. There it is. We reset characters added to 0. Characters added plus plus. Characters added plus plus. And the idea is that even though we may run out of the characters left to transform, we might actually still have characters that we want to add. So we do that here. We do that here, and we want to revisit this subroutine, right, of adding the dominant element. So we do AA, and then this B, when we add this B, here we decrease the characters left to transform. We don't reset, or we don't change the dominant character, but we do increase the number of characters that we've added. And then we go back here. Characters added is greater than 0 now. So now we go through this cycle again, and then we pick up the second A, but we don't add the second B, because we have characters left to transform is equal to 0 now. And then so characters added is equal to 1. Do we care about characters added in the case of the dominant character? No, because we will always hit this second, so it doesn't matter if we add characters by doing that. So it should just end here. And then after that, then we start shrinking it until we get to A. Actually, until we get to B. BA, we get to BA. Then we say if it's greater than or equal to? No, because it'll change back anyways. Then we go there. Well, then once we're here, do we care about characters left to transform there? Because once we have a different dominant character, or like once we shrink it here, let me think. Once we shrink it to that point, does it matter whether or not we have characters left to transform? Maybe we do this. So we go here. We go through this cycle. We add 2 characters. We add another character. We add a dominant character. Then this cycle we haven't added any characters, so we shrink and we try again. We can't add another character, so we shrink again. We try adding another character. We can. Let me think though. Because the point is that at here, at this B and A, at this subset, we have two characters of the same frequency. Or the frequency map of s at right plus 1 or 0 is equal to the frequency at dominant character. Or 0. I think this needs to be wrapped up. So the idea is that as long as we either have a character transform or the frequency is the same, then we can do that. And if we haven't added any characters, then we need to shrink by 1. So we only want to do this once, actually. I think that's fine. Where do you go? You go there, so okay, I need to get rid of you as well. So the idea is that if we haven't added any actually need one more. Need one more for this while loop. Yeah, there you go. So the idea is that while we can add characters, we modify the characters, the dominant character if we need to. We recalculate the number of letters that we have left to transform. Otherwise, if we haven't added any characters, then we will go back to here. We'll go back to here and we'll say, okay, we'll shrink the left side by 1. We'll shrink the left side by 1. We'll remove it if needed. Though I guess removing isn't necessary, technically. Then we will recalculate to see if there's a new dominant character. Otherwise, we just go back here and then we restart again. So it should go here. Start at 0, then 0 and 1. Then 1, 1. Or 0, 2. And then 0, 3. Then it'll shrink by 1 because it can't add any more. It'll add... No, it can't add that one. So it shrinks again. Now it can add the other B. Now the B is dominant. Now we can add another B. We can't add the other A, so we shrink again. Then we shrink again. We shrink again. Now we can add the A. And now we've hit the end, and then we stop. At least that's how I imagine the algorithm working. Let's see how it turns out, though. So 0, 1. Then 0, 4. Let's see. Let's do it more explicitly so that we kind of see what we're doing. It's a little bit more messy, but I think it works a little bit better. So while we're in this loop, and the next character is our dominant character, we can grow to that. Otherwise, our next character is not. And if our next character is the same frequency, then we can do that. Then we can go here. And in that case, we can sort of do this. Sort of take that next character right away. Then we can do a print line inside here. Left to left, right, right. And let's see where we're at. So 0, 1. Then 0, 3. 0, 1. Then 1 and 3. Then we say can't do or can't add more. Shrink by 1. So we do 0, 1, then 0, 3. We can't add more after AABA, so we go to 1 and 3. Still can't add anything, so 2 and 3. Then 2 and 5. Then after 2 and 5, we can't add any, so we go 3 and 5. Still can't add any. Then 4 and 5. Then we can go to 4 and 6. And then we get to that. Cool. That seems to work exactly the way that I want it to. Let's give it a shot with this one, with the first example as well. Cool. All right, let's comment out these. And then let's throw in a submit, and let's see where we end up, or if there are any edge cases that we need to worry about. AABA with or AVAA with 0. We did 4. Let's see. Interesting. It should add, or here, we can't add any more. Oh, because we start at 0, 0. Or we start at 0, 1. Okay, we can start at 0, 0. Max length 1. We don't need the we don't need the dominant character calculation at the beginning then. Index and left to right. Yeah, and then we just do in here we can just do S0 to 1, and we set our dominant character like that, and this should work. Now we should start here. We can't add the A. So while left is less than, or I think we can get rid of this. Or less than or equal to right. Let's see. 0, 0. If left is equal to right, then do right plus plus as well. So we just want to move the entire apparatus if that's the case. Let's see. So 0, 0, and we can't add b. So we shrink by 1. So now we move everything to 1, 1. And that's inside here. Right is less than... Ooh, okay. Right is less than that. Yes. If right minus left is... No, we don't care about that anymore. Interesting. And then we didn't add anything. Well, B we can't add anything, right? So that makes sense. Then we should increment again and then go AA. And then at A, we shrink by 1 here. And remove it. And then right is less than... Then we should go here, right? Just very curious as to sort of max length, right minus left plus 1. Let's see. 1, 1, 0, 1, 0, 0, 1, 1, 2, 3. 2, 3 is correct. I don't know why that doesn't get picked up there, though. Oh, because it's the right side. Okay, yeah. I am interested in why it's picking up on... Three minus 2 is 1 plus 1. That should be 2. But instead it's saying 3. Why is it saying 3? So weird. 1 and 3. And characters less to transform is either greater than 0 or the frequency. The next value is equal. I see. Our current value, our dominant character, what is our dominant character at that point? Dominant character should be B. If our dominant character is B and the next character has a value 0, interesting. do print line, or we can just do this at the start, right? We can just say like print line dom character. I have a feeling then the dominant character is like A or something. Let's see. So this 1 and 3 is not correct. Dominant character here is still A. Print line new dominant or new frequency of S. Oop. S at left is frequency map get at S left. And then print line frequency map. So it's not an issue with this particular line. It's an issue with the other lines. Let's see. We don't need this. Oh, we don't add our next item, or well, we don't want to add our next item. Well, unless we have this. Frequency map put into our frequency map. We can say if right is less than s dot length, then we get into our s at right, or put 0 plus 1. Then we do that. See if that helps. Then our dominant character is B. Because since the left is equal to the right, then we want to add the next character. Then we can't do anything about that. So then we move it over and our dominant character is A. We can add the next A into it. Then we shrink again, but at that point we're already at the last element. Let's just make sure we didn't regress on anything. Looks like we did regress on something. Looks like we regressed on the first test. Looks like we're getting 3 instead of 4. Let's see. We're going to 0, 2, which makes sense. But why can't we go to 0, 3? We add B and then we add this A. Let's see. Characters left to transform. should be, let's see. Print line characters left to transform. Should be 1. Let's see. 0, 1, 2. 2 minus 0 plus 1, that's 1. 2 minus 1 should be 1. So 2, that's 2 minus 0 plus 1, that's 1. No, 2 minus 0 plus 1, that's 3. 3 minus the frequency of the dominant character, which should be 2. 3 minus 2 is 1. 2 minus 1 should be 1. Why isn't this dominant character getting added? I think it just isn't getting updated, interestingly enough. It's not getting updated here. Yeah, 2. But if I actually like toss in this entire equation, it should spit out 1. But it's holding on to 0 because it hasn't updated. Right, okay. Does that add 1? I always imagine that characters left to transform would be net neutral in that case. Well, right increases by 1, so therefore that decreases by 1. Okay, so I think we actually need to do that. If we're adding a print line characters left to transform. Still nothing. Interesting. Then you go down here. Right, because you don't get added again. Do we need to change that? Characters left to transform. We don't need to modify this here. We can modify it within here. And then we don't need to worry about this. Because characters left to transform is only when we're growing. If our dominant character or dominant character changes and updates, then it doesn't matter to us on the outside because we can just take care of it on the inside when we're actually growing. Right. So don't need this either. Let's just make sure we get rid of all the print statements. Okay, let's give it another shot. Let's see where we're at. Okay, this is pretty damn slow though. Maybe there's some way to do this that's faster. Because bottom 10 percentile starts making me wonder if there's something wrong with my asymptotic runtime. Is this not O of n? If I did if right is equal to s dot length minus 1 return, max length. So if we hit the edge, then we don't need to worry about it anymore. Does that work? Because then we kind of we should get rid of a lot of the additional stuff, because once we hit the edge, we shouldn't need to worry about it, or worry about it anymore. Or the rest of the substring. That sped it up marginally, but really not by a significant amount. There's probably a much better way to do this. This is a lot of lines of code for a medium problem. But I'm gonna check this off camera, and if it's particularly interesting, then maybe I'll make a follow-up video. In any case, this is my solution, sort of just doing a sliding window. We grow the string as long as it's either the same as the dominant character, or if we have characters that we can transform. And then afterwards, we shrink the array from the left side. We shrink it from the left side one at a time, and we see if we can continue adding. In any case, I hope you learned something, and I'll see you for the next problem.